So I was messing around with fluid simulation in ShaderToy, and here I implemented a lattice gas automata. By the way, there's going to be some stuttering for this one because my video codecs apparently have a hard time supporting this. But so at each pixel there's four possible like particles it can hold, one traveling in each of the four cardinal directions, and basically what happens is if any particles collide, then like if they're going head on, then they'll rotate 90 degrees. And otherwise they don't interact at all. And what this creates is a kind of really rudimentary fluid simulation, and it's like really noisy, but it works decently well. And then I started it by just populating it with random values, but here I then changed it into what I believe is a lattice Boltzmann simulation, where at every individual pixel, instead of just storing four particles, I store like a degree of how many particles are moving in each direction. What this creates is a more smooth appearance, and you can see how that impacts everything. How you can kind of see waves happening at this point, even though everything is still pretty noisy. There's a little bit more of like an average color that you can see, even though there's still a lot of variation. Uh, but yeah, I thought it actually didn't change very much when I just implemented specifically that. But here I reduced the amount of particles that are redirected from a collision to only a percentage, and it dramatically makes it look better. You can see these like trails happening behind the front of the waves. You can see like these different waves kind of like when they crash into each other, it kind of like eats the other wave and makes it travel in a different direction. But there's still a problem with this where the waves kind of exist forever. They'll just bounce back. As soon as you introduce noise into the system, it never like gets dampened out. Uh, but yeah, it does look pretty cool. But that introduces us into the next one. Here, I actually removed that feature of the collisions, and the only thing I have here is like a blur that's applied. And this kind of just makes the fluid travel from high density to low density. And then here I implemented that in addition to the collision that we had previously. And you can see that what's going on is the waves start out like they did before, but then they dissipate over time. So it kind of makes it I think it makes it look a lot more realistic. Here I implemented viscosity, but I have no idea what I was doing. So I I created some weird thing where the particles get trapped in like these mini vortexes. I think I'll be honest, I don't know what they're doing, but the point is that they don't move. Uh, I don't know. It's pretty cool. I'm not a physicist, but yeah. And then so I was like, all right, what happens if I tune that down a little bit? And here, what we actually have is a slowly like it starts out solid, but then like over time these like it's unstable, so these waves like build up and slowly erode at all of the like stable parts of it until you get these like cool just waves happening behind things. I think the way these interact with each other is just kind of really cool to watch, especially near the borders where they're kind of I don't know, they're like forming out of these lines. I don't know how to describe it, but it's just kind of cool to look at. It kind of reminds me of like Conway's Game of Life a little bit too, where there's just like gliders that are happening all over the place because they kind of like group up into these small waves that are almost like little spaceships. I don't know. But yeah, super cool. You can even see like a weird pixelation effect on some of the waves, or I don't know, I don't know how to describe it actually, but it's like you can they form these like periodic patterns of like droplets like coming off of the wave. Only like every other frame or something. I don't know why that happens. But yeah, uh, basically what I forgot to do was, well, what I did was I canceled out motion that was like if there was horizontal motion coming from the left and the right, then I canceled that out when I was considering how the impact of adjacent cells would uh, kind of influence the current cell, and that produced this. But and here we have is much reduced viscosity to the point where, or as I call it, wacky viscosity. Uh, Much reduced wacky viscosity. And here what we have is like these lines of black forming, and I think what's actually going on here is that at these kind of like plus signs where the vertical and the horizontal black lines intersect, we actually have these vortices occurring. Because when you see like a wave pass over the intersection, you can kind of like see it spiral around it. Yeah, I'm not sure why these form, but it looks really cool. It's like a lava lamp thing going on. Yeah, I could just look at this for like all day. It's really fascinating. But yeah, this is the last like wacky viscosity one I have. I actually coded viscosity in a way that makes more sense, and uh, it probably still isn't physically accurate because I don't know I don't know what I'm doing. But it at the very least resembles uh, actual waves at this point. You can see it's kind of like the how before I implemented the blurring, it actually the waves would go on forever, and here we've got like a nice medium approach where it slowly decays over time, but the viscosity kind of carries the waves forward, uh, so that they're a little bit more long-lived.